Okay, so I think we're live now. Basically, basically tonight we are going to go over adding, uh, basically Sentinel data to, uh, okay, let me see. Is this working? Okay, so tonight we're going to go over adding Sentinel data to, our data set. Um, and so basically the rationale behind that is we are creating a kind of multi-model data set, and so it would be useful to have the satellite imagery of what the river basin looks like, and what kind of surrounding topographical features look like for forecasting. And then similarly on the other end, if we're looking at like predicting, say, crop yields or other agricultural things, having the satellite imagery tied to the various river basins could also be useful. Same with like predicting watersheds and other things. So the idea here is we're going to we're going to add to the metadata the various tonight at least the paths to the buckets containing imagery of that river basin from the Sentinel-2 satellite. Um, so basically, the Sentinel satellite. I'm probably getting this wrong. But there is kind of an orbiting satellite that often updates on every 2 weeks or so, with around 10 meter kind of spatial resolution. So all these files are basically uploaded to GCP in a public bucket, but they're currently based on the military grid coordinate system. So the thing is, if we're looking, in order to get essentially the proper path into our metadata, we need to essentially write code, and then we also want to extract what dates are present too, but that won't go in the metadata. That will probably more go as part of the time series data. Um, Obviously, that will have a lot of nulls in it because I think the revisit period is generally every 6 or 7 days, and in practice, it might be even less. But that's something we'll kind of look at, like I think when we get to it. So, anyhow, basically, uh, yeah, that's one of the things we were going to do. Um, and yeah, so we'll get started with that. So as I said, basically, these images are in these buckets that is in this bucket that, and the paths on this bucket correspond to the military grid system. So basically, um, yeah, under tiles you see like these different things, and similarly on the grid system, you have these different numbers. So basically, if you wanted something for different regions, you have to follow that path. The problem with this, though, is obviously in our metadata, we currently don't have, we only have latitude and longitude. We obviously don't have anything mapped. I'm going to pull up one of our metadata files to these grid paths. Now, something the people did was they did kind of, yeah, this is an example of the metadata now. We have lat and longitude, but that's about it. Something that the people did do with this is they did actually upload it to the index file to a BigQuery thing. So I did do a couple queries to query the index. So we can actually query that. The problem though is that these queries, for the amount of metadata we have, are probably going to get very expensive. But what we'll want eventually is to essentially get this path. So, from these tables. So what we're going to want to do is, oops. Shit, did I close that? Fuck, why did that happen? I think you could, or wait, no. Where did that table go? Thought that was just an empty tab. Oh, there it is. So yeah, so we want to query. We're gonna probably want to query that and get, what is it? Get this, I'd say. This, because then basically what happens in the file path after that is then the instance and the dates, but then we'll need to extract those separately when we add it to the actual temporal data for the site. But for now, we'd probably just want to get these. So, let's see. We might write a query here. So I had this, actually I had a saved query somewhere that I had used in the past. That's definitely not the query we want. Also, this is a pretty big table. So the thing is, we also want to be careful not to rack up a big bill on this data. Now, where is my query? I know I saved one. Oh yeah, so this was one I did. Actually, this turned out to be a bad idea. Because between didn't work with the negative numbers. So that turned out to be a poor query because it didn't return actually what I wanted it to. So actually, I'm not that great with SQL. So I mean, I use it a bit, but but it hadn't been working for negative ones, which had been a problem. So so I guess you could just do comparison. And so we'll do that. So these actually are negative, the west one. So these should actually be this. We'll see if this returns the right stuff. So it obviously didn't. It said there was no data, but I know for a fact there should be for this one. So let me look at something. So yeah, I mean there definitely are negative. Oh, did I do that right? Greater than and less than. North flat between 40 and 41 and west lawn greater than negative 105. Um, 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 I don't know why it's not playing well. I thought these would work with the negative values. Um, so, what if I nest this? SQL value in range. Oh, I don't really want to do row over. Well, it's saying use between operator, but that was causing. SQL between negative. Smaller value first and the larger value second. Okay, I'm gonna go back to that then. Between negative 105 and negative 106. Smaller value. Oh yeah, between negative 106 and negative 105. So something important too here is to see is that each of these is processing about 1 gigabyte of data. Okay, there it goes. There we do see actually returned a lot of results. For that, about 1,500. But one of the things is these are generating each query is performing about 1.4 gigabytes of data. Now I do get 1 free terabyte, everyone does, per month. But I literally have thousands of stations. So if each of these is doing that, then that's going to probably be more problematic. So we also want this. That's why I said in the beginning. Let's see. Why can't I see the edge? I really need to see the edge to know what it's doing. So, yeah, always pay attention to this number. So obviously, if for some reason your query just runs a ton of data, then it's going to be problematic. So this was actually for, I think, Boulder Creek, which was in Colorado. So it looks like the tiles that kind of cover where that gauge would be between these. Now, so it would be this 13DE and 13TEE. Now what we could do, obviously, is we could write some script that would query. Did I save that other one? I want to see my recent stuff. Oh yeah, there it was. That could basically take from the metadata the latitude and the longitude. Would I really call that longitude? That's going to be problematic. That should probably be fixed in the data too. But in any case, that takes these and subs them into a query like this, and then gets the different tiles that these correspond to. So we'd be then querying between, each of these. And yeah, so this would be the west. Yeah, I think that's right. 106 and 105. So yeah, we could do that. Or the other thing we could do is this is obviously the index file. We could download that and try to load it into a big Python data frame, and then that would not use up all of our GCP querying power. So I might actually try to do the latter on that, and then we could just query in pandas these things. So I think they threw that in the bucket to begin with. So this was basically a freer, probably a lot bigger than 3 gigabyte CSV file. Contains exactly what that big query table contains. So yeah, we could try to do that as well. So I'm just going to see how easy it is to do that and how long it seems to take, whether this can be even loaded into memory. Because if we could do it that way instead of querying BigQuery right now, we won't end up wasting money or even our free terabytes. So so that would be useful. Read Sentinel. Okay. Okay, so we'll do that again. I think we have to off somewhere. So basically just go here. We'll copy that code. And we'll see how that works. I will save that query though, just in case I do come back to it. You can save queries, I know, on GCP. So save query. So, anyways, we'll download, we'll see what happens here. Yeah, wow. So, yeah, it's basically a large file. I don't know where it's gonna download to. Might download just right here. Oh shit. So yeah, it's taking a while to download. I think it's about 3 gigabytes. Well, we'll probably have to un-gzip it too, actually. I wonder if that will work. Unzip gz file collab. So yeah, it looks like that. So we'll have to do that to here. So we'll just do that. We're just gonna call it content. I don't know. Index. Yeah, we can just call it index.csv. Let's see how that works. So yeah, and I mean in pandas too, I think we well, we'll probably query it using indexing, I think. Cause that would probably be faster. There is this thing where you can actually now just write SQL on a pandas thing. But my guess is that would be slower than doing it a more indexing route. And this is going to get called an awful lot. So while that's going, we can begin to write a function to I guess get some of this shit. So def query df meta at meta launch, and then so Oh shit. I really just do that. Okay, so yeah, if it's gonna happen now, we'll probably... If it is gonna cause an out-of-memory error... Well, it could happen later, too. But this will be the first test. What? So that's where I just extracted it to. What? Didn't the extraction work? What? I thought this worked. I don't know what the fuck. Thought it failed on that later part. I don't know. Like, what just happened? I mean, I was sure it had actually extracted it. Maybe that thing isn't working. I don't know. Well, now I'll wait till the end again. So what? In any case, yeah, so I think... Oh yeah, how was I doing this? Yeah, I think basically this we'd round up and then round down. What? No, I want you to extract it there. What the heck? Like, this shouldn't be that fucking hard. Should just fucking, like, I don't know what the heck was that. I made that. So it's index.csv.gz. I don't know why that tar thing didn't work. Yeah, I mean, it is a large file. I don't know why the tar thing didn't work. Oh, I guess maybe it just should have gone to a destination directory. So I guess in that case it would have just been something like that or something. I don't know. Hopefully this .gc actually extracts it now. Yeah, if the .gzip just does it, then that would be fine. Okay, what? In any case, I'll work on this now. Okay, so index df. So I think we'll want to round up and down for the between. Would be my guess. Okay, so we'll need to import math. I also want to do round down. Okay, math, yeah. And then that's what we'll do for the between. Okay, so that unzip it. Okay, finally did it. We'll finally open this. Should have just done that to begin with. No stupid paths with that. So yeah, hopefully this will load now. Though it may take a while again. It's very possible though we'll run out of memory. I have definitely run out of memory on these before. So it definitely wouldn't be the first time. Okay, so obviously we're not going to see the exact lat or longitude in, but that's why we're going to do kind of a range. Yeah, and it just ran out of memory, I think, or maybe it didn't. Okay, I don't think it has yet, at least. So 4 lats, so math.4, just import. I'll throw the import up there. Really, I like to import everything at the top, kind of like it's an actual script, which it will be in a bit. Seal lat. Oh shit. Index, I'll have to look at this. Then basically we're going to do, think you can do that? I think that's how you do a pandas where, essentially. And there is the dot where thing. Yeah, I mean, I think we can throw that between two numbers, right? Or I guess we can see. Oh, it did crash. Shit. Didn't have enough RAM. That's really sad. I don't want to have to download that again. I don't know, maybe we will have to query from BigQuery. I'm going to attach the higher RAM, see if that works. If not, we may have to query from BigQuery. Or, I don't know, I could try it locally too, I guess. I don't think this Mac actually has that much RAM. Yeah, I mean, it has 16 gigs. I mean, this shouldn't be that bad of a file, though. I mean, zipped, it's 3.1, so you'd think even unzipped, it wouldn't be bigger than like 6 or something, right? I think we now have to rerun all this bullshit though, which is really annoying. How much RAM do I have here right now? Well, I'm already using 12.3. If I closed all this other shit, I could probably maybe make it work here. I'll see if it works in collab first, though. Not, I could definitely try a Jupyter notebook locally, I guess. Or, I mean, I could the other thing would be spin up a instance here. But at that point, I feel like it might as well just use GCP. Or I just use BigQuery, because then I'm already going to be paying for it, probably. Let's see. And I have something, I think, like 6,000 gauges. So if each uses like 1.5 gigabytes, that's 6,000, 9,000 gigabytes. Yeah, there's 1,000 gigabytes and 1 terabyte, I think. Yeah. So, yeah, that means I'd use 9 terabytes though, which would use up my monthly a lot more than my monthly allotment. So yeah, I don't want to do that. God damn it. Okay, so it is on high RAM now. Yeah, I mean, I guess then I really would have to try to do it locally. Which would obviously, I think, be more of a pain. But yeah, there's no way I would want to. Let me look. I'll have to check BigQuery pricing. Because, yeah, it only gives you, I think, 1 terabyte free. And then. Well, then I guess it's 6.25 per terabyte. But the thing is, that's already going to be. Yeah, essentially 8 terabytes. 8 times. So that would be about $50. I mean, that's not a huge cost, but I'd rather just not pay it. I think I might have more gauges than that too. Okay, well, I'm gonna let that run. I think for this, then I could do like, where was this? Yeah, that's how you do it. Index df. Let me look. Oh, yeah, here. No, just equal that. I think I can do that here. Seal that. I think this was just latitude. Or no. It would be think nor flat. Yeah. And this would be. So we filter that first. I think these would work. So this is taking forever though, just to load it. Or well, just to unzip it. I haven't been able to load it yet, actually, so. Yeah, I don't know, maybe BigQuery. Really don't want to pay like $50 though. So, I mean, I don't know how big this thing is when it's unzipped. I mean, it's obviously 3.1 in total. I just download it here too. What's going on? Is this still running? Can't tell if it's running or not. Hope it is. Or wait, yeah, so we take that from that. Yeah. And then we just, return index on filts. I think that's right. Okay, why is saving failed? Yeah, just overwrite the shit. Wait, how do I just overwrite it? Yeah, I don't mind overwriting it. I know this is the most recent. Just overwrite it. Okay, I can get rid of that. What's going on? Don't like this at all. Seems to have just jammed again. Okay, well it's saved at least, so that means I can refresh it safely, I think. But we'll have to see where it's working. Okay, so it looks like it's still trying to load this giant CSV file. Isn't this like one of those data scientist interview questions? What do you do if you get like a giant CSV file that won't fit into pandas? The correct answer is get more RAM. No. Yeah, I don't know. I probably could fit it. I mean, it says I'm already using a lot, but I could close windows and some space is already allocated here. How long does it take to load this stupid thing? BigQuery wouldn't cost at least $50. I might just do it there. I mean, I'd still have to write some of this in Python, but then we'd call BigQuery from Python probably. Oh my god, this is taking forever. Oh wait, I think it got downloaded here. Oh wait, no, it failed to download. I mean, it is a really big CSV file. I mean, it's at least 3.1. Oh shit. That actually work? Okay, so it actually loaded the file after only like 2 hours. Okay, there we go. Wait, what happened to the headers? Shit. Does it not know that those are headers? Shit. If it doesn't know those are headers, that's going to be a problem. Oh, wait, it might. Never mind. I think it's just the way it displayed. I hope, at least. I hope. Let's just try product ID. Okay, yeah, it was just the way it displayed. Okay, so now what was this complaining about? It didn't like this. So what doesn't it like there? Oh, shit. I didn't actually do that. That's probably what it didn't like. Math.co. Meta. Oh, why did I delete that? Okay, there we go. So I think that's what we want. So we're going to try this. So, okay, what was the query we had here? Okay, so let's just say this shit was like negative 105 something. Basically try to replicate that and see if it works. No, latitude was like 40. So I'll just say it's like 40.1 or something. Yeah. No, not 400. 40.1. And then we'll just say it's like negative 105.6. And then we'll do cent index. Key error nor flat. So that's what we had there. There was definitely nor flat here. So that these things were identical. Oh, it's all caps. It's all caps here. nor flat. So if this is right, it should basically produce that same list that we had there. Truth of a series is ambiguous. Pandas query data frame in range index. Okay, but I'm not using those. Oh. Do I need to do that inside there? I might. And I need to do this shit in here. I don't know. Maybe I can't do that in pandas. But I just write and. What? I want all of them. Thought this would be simple. Okay, that's not what I want. I don't know why this isn't working. You'd think it would work. Maybe I do have to write it the other way, though. Oh, shit. Fastest way to where query in where query. Oh, I think that's called masking. Okay, I don't know. I mean, I might just try. No, why does I keep doing that? Oh, because I keep hitting the back thing, I think. Okay, so... Um... Okay. So... That's... Yeah, we'll do equal just in case. Let's see if that works. Okay. Actually, that seemed fairly fast anyways. So we do the same thing here, except with the long. Okay, let's try that. 1558. Is that the same number? Okay, yeah, so it looks like they return the same shit. I mean, this still has everything, but... But yeah, these look right, too. Okay, yeah, I think that's all I'll do for tonight, but, yeah, having the query working that way, I think should save a lot of money, because then we can just kind of, loop through the metadata files to get those, rather than, querying BigQuery that way for every single one. So, yeah, that will probably be the end for tonight. But, yeah, I think once the Sentinel data gets added, it should be interesting. And then, yeah, it's just, yeah, it's just going to take a while to probably run the script. I mean, this notebook will kind of finish off by then, yeah, pulling the metadata and then looping through, opening each meta file, getting the things for it, then re-uploading it to the bucket. So, but yeah, any case, yeah, that was kind of the beginning of that, and then, yeah, once we do that, then I will have that in the meta file at least, and then actually we should probably cache these things maybe in somewhere too, so that then it's easier to then have the URLs that we can then pass to the kind of more temporal files when those are constructed. So, um, but in any case, in any case, we'll end there for tonight, and then should be back, I think early. Some other day this week, probably Monday or Tuesday. Okay, so